welcome guys. Welcome to one more video from Captain Sato. See, we are all living in a world where the pollution is main issue now. Air pollution is increasing day by day. We are breathing gases. We don't know what's happening around the world. But luckily, presently I am sitting in a place where the atmosphere is very good and I am breathing very good air, and hopefully the oxygen is 20.9. So I am lucky to breathe good air and good gases. But not all the time you will be lucky. So sometimes you might have to enter some spaces where the atmosphere will not be how you like, or it won't be very pleasant. You might have gases, you might have so many other things. So today we are going to talk about instruments that can help us find gases, that can help us save our life and our fellow seafarers' lives. So this is the topic for today. So let's go ahead with our topic. So today we are going to see what equipment we have, and let's try to learn a little bit more about the requirements of SOLAS and requirement of ISGOT. What are the requirements and these instruments? Let's see. So let's see first what we have. See, we have got a portable gas meter GX8000. This gas meters can detect oxygen and other toxic gases. And then we have got a sampling hose for this. See, we have got a sampling hose, and this is the connection which will be connected to vapor lock. So this is the connector over here. Then let's see what we have else here. Okay, we have got a sampling bag now. Whenever we want to do calibration of this equipment, we have got a sampling bag. Then we have got a regulator over here. This is the flow meter. So this is the flow meter which will be connected to the span bottles. Then we have got one more regulator over here. And then we have got a personal gas detector. This is the personal one which you will be carrying with yourself and when you're going into your enclosed spaces. And then this is the span gas over here. We can see this is the span gas which will be doing the calibration. And over here we have got dragger pump. Sorry, not the dragger pump. This is the gas tech pump for checking the gas, this toxic gases. These are the toxic gases over here. Few toxic gases which are there. This is for benzene, and this is our gas tech pump. And this is a hose which will be used when you want to check the gases in the tanks. So this was all the equipment that we have today on board, and we are going to see more details about these equipments and how to use them, how to calibrate them, and how to keep them fit for use. Okay, so let's see now some regulations which require these instruments to be on board. So let's okay, you can show over here what are the requirements. You can see over here the requirement from SOLAS chapter B, chapter 2B, regulation 4. So it says that we should have a gas measurement and detection system on board which can detect gases on board. Then if you are carrying your cargo as bulk cargo as oil or any cargo which can have oxygen deficiency, then you should have an oxygen meter on board. So this is as per SOLAS part A, chapter 6, regulation 3. Then you have got an IMO MSC circular also which states the requirements. And then we will also see now some other ISGOT requirements are there. So there are a lot of requirements which mention about this. Also, I would like to say these gases you cannot see these gases, you cannot feel these gases, you cannot smell these gases till the time they have actually overcome your senses. So if you're not able to sense them, that means they have already overcome this your system. And these gases can be very poisonous. These gases can kill you and they can strangle you. So now let's see how we can detect gases with our senses without using these gas meters. What signs our body is going to give us that we are into some gases or we have some gases around us. So my friend now he will tell us some indications that we have some gases around us. So what do you think? How will you come to know you have some gases? You've been to enclosed spaces, right?
Yes.
So tell me your experience. What are the signs?
Sir, if the space is oxygen deficient, then you will have oxygen difficulties,
Okay.
and you will have eye irritations.
What about if you have some gases? So what are the signs of gases?
Sir, like eye irritation, skin irritation,
Okay.
nausea, and difficulty in breathing.
Okay.
This kind of problem you got.
You might have dizziness also.
Dizziness.
Okay.
Dizziness is also.
And you will have sore throat sometime.
Sore
When you're
throat,
breathing, you
yes.
will have some
Yes, sir.
irritation in your throat. Okay. So regarding oxygen now, so we will talk about oxygen. So we can see here now how will oxygen is going to affect us. So the normal oxygen is 20.9. Okay, so this is the lowest allowable level for entry, And when you have 15% oxygen, you will be deep breathing and high pulse will occur. At 10%, what will happen?
Dull action and
Very heavy
heavy
breathing. Okay, so this is what's going to happen. And when it comes to 6 and 4, it's going to get more difficult. And at 4%, at any time you can fall unconscious. Maybe 30 seconds, 40 seconds per depending on person to person. Okay, so today now we are going to start our training for these portable gas meters that we have on board. So you can see we have got 2 gas meters over here. Now these gas meters need to be regularly calibrated. It will depend your company procedures, it will depend how your company wants it, but normally these will be calibrated on a monthly basis, and before you make an entry into a tank, it is required to be calibrated. Because if you don't calibrate this equipment properly, they will give you some irrelevant readings, and if you basis on that readings, if you make an entry, it can harm you, it can harm people, and you can have devastating results. So let's see about this equipment. Now this equipment has got a battery, and this battery life of this equipment is of about 12 hours. Okay, so the equipment has got a battery of 12 hours, and then you have got some sensors in this. This equipment can show you gases of hydrocarbon, carbon monoxide, oxygen and hydrogen sulfide. Same way, we have got this equipment, small portable one, which we are going to carry it, and you can clip it onto yourself. We will show you how to do that. So this equipment also gives you gases H2S, carbon monoxide, LEL and oxygen. And it has got sensors. Same way we have got sensors over here. So the replacement, we have to replace these sensors from 20 to 24 months depending on how you have used them. So both the equipments have got sensors. These sensors need to be replaced for 20 to 24 months. And battery life of this one is more, so this can last about 24 hours. Okay, so this is all about now. Now this, my friend, he's going to tell you about this instrument, how its switch ons, its basic functions, other buttons and basic functions about these equipments. Okay, so hand over to him now. He's going to tell you about this equipment and this one.
So basically this is our portable gas meter GX8000, as you can see over here. Here we have 4 buttons over here. This is the display button and this is the power enter button. The power enter button function is basically to switch on the gas meter and to switch off the gas meter. And here is the reset button to reset the alarm, and this is the air calibration button to air calibrate the gas meter. So basically this is the display panel of the GX8000. Here you can see this is the alarm indication display. As you have any alarm, it shows the red light over here, and the gas meter will continuously give you the alarm of the presence of the toxic gas.
Can you also tell me where are the sensors, battery and other things?
Yes sir. So basically the down part of this gas meter contains the battery, and here inside it is all the sensors inside the gas meter. As you can see over here, this is the gas sampling point of this gas meter, and this is the gas out point. So basically it takes inlet of the gas from the silver one.
Oh, good. So now you can switch on the equipment, and then let's see how it looks like when you switch it on.
To switch on this equipment, we have to hold this power button for few seconds.
Okay, so you get 2 beeps.
Yeah, yes.
Okay.
So as you can see, it's switching on now.
See, if you can hear, there is a pump which has started now.
Yeah.
So if you can hear in the video, you can hear it. You can see a pump. You can hear a pump which is running now. Okay, good now. So let this equipment get on now. So you can switch on the other one also.
Same procedure for this equipment also. For personal gas meter, here's the power button. We have to hold it for a few seconds and we have to release.
Okay, so now these equipments are getting ready now, warm up. Before we can use this equipment, normally you should wait for 1 to 2 minutes. 2 minutes, roughly 2 minutes time before you can actually use this equipment, even for calibration or for actual use. So once you switch them on, you should not directly start measuring the gas. Okay, so we should wait for about 2 minutes. So now our equipments are on, and let's see now how it looks like and what is the reading now.
So
Okay.
as you can see now, it's showing hydrocarbon is 0% LEL, and oxygen is 21.6, and H2S is 0.0 ppm and CO is 0.
So this is what, see, now we have got another gas meter over here, personal gas meter. It is showing 0 and it is showing 20.6 and 0 and 0. So what we should do now? You see, we have got 2 meters, both of them are showing different readings. So as a basic, as an operator, what you have to do is you have to do air purge. Okay, we have got, you can see over here, we have got this air button, and then we have got air button on this one also. So you can purge for this and I will purge for this. So you can see together, you can see how to purge both the equipment. Okay.
For purging,
just zoom out little bit.
For purging, for air calibration, just you have to press this air cal for some. It says hold here and now release.
Release. So we release this one. After you release, it's going to air purge. See. Now it has done air purge and now you can see your equipment is showing perfect. 0, 20.9 and all other gases are 0. So this is how a purging is being done. But for this meter, it takes some time. Okay, so this is how you can see it's doing now. There's a countdown going on. Once the countdown is finished, you will have proper readings. Yeah.
And sir, just for information, the air calibration should be done inside the accommodation only, not on the deck, as it contains the toxic gases outside.
So he is very right. You should do it inside the accommodation when you have gases on deck. But when you don't have any gases, we can do it. And because these equipments are intrinsically safe, so these equipments are intrinsically safe, we can use it on tanker, we can use it on deck. Yes. Okay. So let's see now about calibration of this equipment with span gases. We already seen how to do the air calibration, so we will see about the calibration now. So what all equipments and attachments you require for calibration? This is the personal gas meter over here, you can see, and this is an attachment which is required for calibration. And in this, if you can see, there is the flow direction is given. So in which direction you have to put the span gas and which direction it will be coming out. And for putting the span gas, we have got this span bottle over here. This is the span gas bottle. You can see we have got 4 gases in this, and these gases are hydrogen sulfide 25 ppm. Then we have got carbon monoxide 50 ppm, and then we have got methane, which is about 2.5% by volume and 50% LEL. And we have got oxygen, which is 12%. And the balance is nitrogen. So this is a bottle now which we have got for span gas calibration. Then you have got a flow meter over here. This is the flow meter. You have got a knob. You can adjust the flow of this gases, how it is going. And then you have got this flexible hose. This hose will be connected to this instrument over here, and then we'll be calibrating. And for calibration of this equipment, GX8000, for calibration of this equipment, you need the same equipment over here. You need the same gases. We have got these gases over here. And then these gases have been already filled in this calibration span gas calibration bag, collection bag. So we have got gases in this, and then we'll be calibrating. Now my friend will be demonstrating you how to do the span gas calibration of this equipment and also this equipment. Okay.
So sir, basically to calibrate this GX8000, just you have to press this 2 buttons together. This is the display and reset button. As we press this 2 button together, the GX8000 will come directly on the maintenance mode. As you can see, it's written over maintenance over here. So by pressing these 2 buttons up and down, we can go on a single calibration and auto calibration mode. There are 2 types of calibration, single and auto. So on auto calibration, as we go power enter, it shows the value. As you can see, the value hydrocarbon is 50% LEL, oxygen O2 is 12, H2S is 25, and CO is 50. The same as the multi gas bottle. Multi gas bottle also the content is the same. So basically, for calibrating this auto cal, we need this multi gas.
So basically, the gases reading is already fed. So you are going to connect the gases, and then it is going to check whether it is matching or not. And it will give you a result that it is pass or fail.
Pass.
So that is what is auto cal. And what is single cal?
So single cal is basically
okay, let's see how the single cal mode. We'll go to single cal mode.
So as you can see, I have not put it gases now, so it's showing me fail. So okay. I'll press the enter button over here, and by pressing these 2 buttons, I'll go on one calibration. This is called single calibration. When I press enter, the single calibration basically means that you are calibrating a single gas, that is hydrocarbon or oxygen, by by a single gas bottle.
So basically, what you are trying to say is that we will be calibrating one gas at a time.
Gas at a time.
In auto calibration, it will check all the gases together. It will check all the gases which is already fed, whether it is matching or not. But say for some reason, if it is not matching, you want to calibrate only one sensor. So you are going to put one gas and you will go to one's calibration mode and you can calibrate that.
Yes.
Right? So that is what is single gas calibration. Now we will go see this one. Okay, how to go in the calibration mode.
So as you can see, this is GX8000. So I'll tell you how to go on this on maintenance mode. Just we have to press these two buttons together, and as it gives two beeps, I have to just release it. So as you can see now, it is now on maintenance mode. By pressing this air button, we have to go ahead on air calibration. This is air calibration, this is auto calibration, and this is one cal. And now I am going to show you how to calibrate on one calibration. On one cal, I am going to calibrate this hydrocarbon now. So basically I have to just connect this flexible hose on this, and I have to press this.
And you have to wait for about 2 minutes, roughly 1 to 2 minutes for the equipment to settle down. And one more thing is this equipment is intrinsically safe and also waterproof, and it will give you a very loud sound when it alarms. So what is the reading now?
Sir, as of now it's showing 42.
42 of?
It came now 45. So as it is showing 45, so bottle content is 50. So we'll go up by pressing this air button.
Okay, so you're almost there now. We are 50, so you can press.
Okay, so now this is end. So
this is how we have done the calibration now. Oh, very good. You can switch off the gas. So now we have just seen how to do the calibration. Okay, so very nicely this gentleman he has shown you how to do the calibration. Very good, thanks. Okay, now we are going to talk about gas tech pump which we have on board. So why do we need this gas tech pump?
So there are some specific gases like benzene, H2S that we have to check on the below ppm that the normal portable gas meter didn't show us.
Okay, so sometimes we have got gases which our portable gas meters will not show, and sometimes we have got gases which our gas meters cannot read. So we have got some specific gas tubes which will give us the concentration of gas in that atmosphere. Okay. Now let's see what we have over here. So we have got gas tech tubes. Okay, this is the gas tech tube for hydrogen sulfide. Then we have got for benzene. Then what we have over here is we have got this hose for taking the sample of the gas in the tank. So this is a meter which is about 30 meter. Okay, so this you can see over here. This is a hose of 30 meters which will reach the bottom of the tank, and then this is the gas tech pump case. So this is the gas tech pump which we have over here. So this is how a gas tech pump looks like. Okay, so let's see a little bit about this gas tech pump. So this is the place where you will be connecting your tube, and this is the breaker where you will be breaking the tip breakers basically, and then you have got a small latch to hold it, and then this is the knob over here for pumping. So this is all about the gas tech. Now let's see how to do some checks before doing the testing and how to check. So my friend is going to tell you how to do the checks and what checks we need to do before testing.
Yes.
Okay, so
First we have to do the. I'll take one gastric tube from this.
So what he is doing is he is putting the tube now in this gas tech pump for checking air leak. When we are going to suck the gases, it should not suck the air from surrounding. So this is how he is going to check now.
As you can see, it's very hard to
So
pull the
yes,
lever.
yeah.
We have to wait it for 5 minutes. As you can see, the white indication is not here or here. When the white indication is here, like we have taken the sample. So now it's not leaking and it's not showing the white indication.
Okay, so this is how we are going to test. We are going to pull it hard, and now it is holding in this position. And if it was going to leak, then you will have here white indication, which will show that the air has already passed. So this is not happening. So how you are going to release it? You just switch and make it very easy, because it's got a vacuum, so it's going to pull it hard. Yes. So this is how we will do the testing. Okay, so let's see now how to check H2S gas if you want to check now. So this is the box for gas tech tube H2S. Okay, it is showing number 4L hydrogen sulfide. So this is a tube which I have taken out now. If you can zoom and show him. So what do we have here? We have got an arrow over here showing the direction of the flow, how the gases should pass. So it will come from here, and this is the side you will be connecting to the pump. Then it is showing you the range. Now see, you can see the range. Range is from 10 ppm to about 120 ppm. So this is the range here, from 10 to 120 ppm. And if you see here in the bottom, there is n is equal to 1. We have got a reading of n is equal to 1. So which indicates that how much pumps you have to give on this stroke. So we have to give 1 stroke of this pump, and then we have to wait for the readings. So how the readings is going to come over here? Now you see over this, it's clearly given in this gas tech tube 4L tube box. It gives you all the information. This is the measuring range over here. So the measuring range is from 10 to 120, we just saw now. Then it is next is number of pump strokes. So we need to give 1 stroke, and then there is no correction factor because we are directly using this pump. And what is going to have sampling time? So how much time you have to wait? You have to wait for 45 seconds for 1 stroke of the pump to finish. And then what will happen? This white color. Okay, now you see this white color. We have to wait for 45 seconds. Then this white color is going to change to brown color. So how you are going to get the readings? So for readings, how do we read the readings? Now we see in this over here. If you can zoom and show, this is how a reading has to be taken. If you get a good reading, you can see over here the reading is 5. It's very clear. This portion is white and this portion the color has already changed. So this is the reading 5. Now if you see down, sometimes you will have a reading in such a way that you don't have clear cutout points. Your reading is inclined going from 6 to 4. So here also our reading will be in the middle. So we will consider our reading as 5. You can see there are 2 examples over here. One, you have got a slant line. Sometimes you might not have a line. It might be curvy. So you have to take the maximum and the minimum, and in the middle you will get the reading. And sometimes you might have sometime you will have reaction, full reaction, like it's showing dark gray over here and light gray. So again we are going to take in the center. So our reading is 5 here. So these are the different examples of reading of 5. So this was how you will check the readings. So we will wait for about 45 seconds and then you will have a reading. So now let's actually see how to take a reading. Now my friend is going to break this tube and he's going to pump, and he's going to wait for 45 seconds, and let's see, do we have any H2S in this atmosphere?
Yes. Here we have to put, and we have to break the tip of it. There is a tip breaker. Yeah. Now I broke this tip.
So you have to break it from both the side, correct? So you have to also break it from the other side.
Yes.
Okay. So now the tip is broken. Now we have to fix the hose inside. So what he's doing is he's connecting it to the tube. Okay, he's connecting it to a tube so that you can lower it in the tank and you can get the reading. Now one more thing I would like to point out over here. See, whenever we are connecting this equipment to your this flexible hose, we have got a correction. So you can see here, for example, if you were using carbon monoxide 1 liter, so this is the gas, and if you do 1 stroke, it's going to suck about 100 ml of air. Okay, and if you got half stroke, it's going to suck 50 ml of the air. So we have got a correction of 1.13. So you need to multiply number of strokes into this. So basically you have to do 1.13 strokes That is what it indicates when you are using this this hose. Okay, so this is the correction factor which we have to use. If you are not using this hose, you have to use directly the number of strokes which it mentions on the tube. So now he is using this, so he has to do 1.13, which is again close to 1. So we are going to do it once.
So as you can see now, I just put this tube on this sampling hose. Now I'll pump it. So for pumping it, you have to pull this lever. For this is the 50. Now we have to go till 100. So as you can see, this is the 100 reading over here.
So it is full. Now how will you know that your pump is sucked full?
So it's showing the white indication over here. So as you white indication shows that the air has already passed in the tube.
Okay. So now what we will do is we are going to wait for 45 seconds.
45 seconds.
Okay. So okay, let's wait for 45 seconds and let's see what happens. So till that 45 seconds, I will show you a few more things. You see normally how we have got this gas tech pump, and these are the different kinds of gases normally which we can measure: mercaptan, ethyl mercaptan. Then we have got other kinds of mercaptans over here. We have got benzenes. So these are the kinds of, and then you can see over here the ranges that you can measure about 0.5 to 4 ppm, and measuring range is 0.1 to 8 ppm. Okay, so this is how you can do. And also one more thing I would like to emphasize over here: what do you understand by ppm? ppm indicates parts per million. So if you have got 1% of gas in your atmosphere, if you have got 1% of gas, that is equal to 10,000 ppms. So that is how ppm is linked to percentage of gas. Okay, so I think 45 seconds has passed now. Let's see what's the reading. Are we sitting in an atmosphere where we have hydrogen sulfide?
Let's check, sir. Let's check it out. As we can see from outside, it's showing that the clear reading. It's not.
There is no H2S.
No H2S inside.
Okay, let me take out this for you. Okay. See, we can see here now. It's all white. So we are lucky to sit in an atmosphere where there is no hydrogen sulfide gas, and he has put it correctly. So this is how we are going to test for our hydrogen sulfides and get other toxic gases. So I hope we have learned a lot of things, and we know now how to check gases and how to escape from these gases and how to dodge these gases so they don't come very close to you. Right? You know what to do.
Yes.
So we need to know our instruments and we need to check it rightly and the right way.